Hello everyone, and welcome back. So we're going to be doing another example on energy today, and this one seems like a doozy, but it's not actually terribly hard. It's extremely hard. It's, okay, sorry, I have to be stupid. It's a condition. So most of this is just setting up the problem. So in the Space Shuttle Columbia accident, it has been estimated by the review board that a piece of foam insulation with a mass of 1.67 pound mass caused the damage to the shuttle tiles, which caused the explosion upon re-entry. It has been simulated that the velocity of the piece of foam relative to the shuttle was 545 miles per hour. How much energy was transferred to the shuttle in the impact in units of joules, assuming all the energy is transferred from the foam to the shuttle? Okay. We have a mass, we have a velocity, kinetic energy. So kinetic energy is going to be equal to 1/2 mass times velocity squared. And as a note, it's relative velocity is usually what you need for this if you're doing kinetic energy compared to something, but just velocity. Don't worry about that too much. 1/2 mass times velocity squared. Now we need to get this in the right units. So I'll need meters per second for velocity, and I'll need kilograms for instead of pound mass. So let's do some converting and figure things out. I'll do miles per hour to meters per second first. It's not terribly difficult. I'm going to do it all in one step, so make sure you follow along. So first off, 545 miles per hour. Convert miles to meters first. So there are 0.621 miles in 1,000 meters. Remember, 1,000 meters is a kilometer. That's technically the conversion from miles to kilometers. I'm just going ahead and skipping a little step to make it easier. And then how many seconds are in an hour? Well, 1 hour is 3,600 seconds. Hours cancels, top, bottom. And miles cancels, top, bottom. All good. So I'm going to plug this in and see what I get. So 545 times 1,000. Apologies. Divided by 0.621, divided by 3,600. It's going to be 243.8 meters per second. They're 243.8 meters per second. I have no idea why I decided to jump over it. Okay, then what about mass? Well, mass is easier to convert. So 1.67 pound mass, 2.205 pound mass per kilogram. And that's going to be equal to, I need a space to put it right here, put it over here. And let's pull up my calculator again. 1.67 divided by 2.205. It's going to be 0.757 kilograms. 0.757 kilograms. Okay, so I have pretty much everything. Now let's plug it into our equation. So I'm going to erase some stuff to give myself a bit of room to work. It's not terribly hard. My eraser's not working anymore. That's interesting. Oh, there it goes. Just being weird today. 1/2 times 0.757 times 243.8. Make sure that you actually write your units. I'm running out of room, so I'm not doing it today, but you should. Okay, and then finally plugging this into my calculator. 0.5 times 0.757 kilograms times 243.8 squared meter per second. 7 times 243.8. It's going to be 225,509 joules. But as usual, I plugged something wrong. I'm looking at it now, and I did 0.757, then I did 2,443 meters per second for one of these. That's a much bigger number. Okay, let's try again. 0.5 times 0.757 times 243.8, good, times 243.8. 22,497 joules. That's a lot of energy. That's a whole lot of energy. Okay, now let's see if that's correct. 22,494 joules, I'm good. And all the steps are right here again, so you just want to pause, look at this, and see all the steps again with a little bit better handwriting. You can. Okay, but as you can see, that small piece of foam was moving at extremely high velocities. And because of that, it had a whole lot of energy to impart. So even small, very low mass items can have a huge effect on you because of how energetic they are. A good way to think about this is radiation. Radiation, you might be like, well, what is radiation? Well, what's honestly happening, I mean, partially, not everything, is radiation is just a very small particle shooting through your body with incredible energy. And it messes stuff up. If you have something shoot through you like a bullet, it's going to leave some damage. And so that is part of what goes into radiation sickness. Not everything, there's a whole lot more there, but it's part of what goes into radiation sickness. So stay away from radioactive stuff. Okay, well, I hope this helps you, and I'll see you next time as we go through some more examples. Bye-bye.